Okay, guys, we're live. Okay, so what we're going to do is, again, we're going to derive the quadratic formula. Let's make sure I don't have this on mute. Okay, good. All right. So has anyone ever seen this before? Deriving the quad form? Like going, you have, Heidi? So going from here, so going from 0 equals ax squared plus bx plus c to the actual quad form. So that's what we're going to do. I'm going to actually show you how that works. So we're going to start with standard form. And we're going to do this derivation using a process called, which you guys should already know, complete the square. We actually talked about this yesterday, so it should be pretty fresh. Okay. You guys remember the first step? Yeah, go ahead, Matt. Right. So what you want to do is gather the x squared and x terms on one side. So that should be the same from the notes yesterday when we talked about 4.7. Gather x and x squared and x terms on one side. So in this case, you get ax squared plus bx equals negative c. That's an easy step, right? That'll be 1 point. So at least you're on the right track. Okay, what do you think is the next step? Divide by a, exactly. So what I'm going to do, I'm going to call this step 1a. And I'll call the next step step 1b. Yes, and I'll put it in, actually, I'll email it to you guys. Yeah, because I'm going to upload to YouTube once we're done. So it's for everyone. Plus, I don't want to figure out who's not here. It's just easier to email to everyone. Okay. So, guys, thanks. All right. So divide both sides by a. So in this case, how would the equation look now if I divide everything by a? Go, Will? Very good. Remember, the whole purpose for doing that is that we want a perfect square trinomial. Remember, a perfect square trinomial, which I'll write up here, is when you have a squared plus 2ab plus b squared equals that, a plus b squared. So remember, we want to be able to make a quadratic look like this so that we can factor it. So that's the whole reason for doing that. Now we have x squared kind of all by itself in some fashion, right? By the way, why do I think I call it step 1a, 1b? Do you have to do step 1a first? Not necessarily. You could divide by a first and then gather the x squared and x terms. It could be, but if you divide everything by a first, you have x squared plus bx over a plus c over a, then move the c over a to the side. So it's kind of interchangeable. All right. So now we're going to move on to step 2. For step 2, we're going to complete the square. Now remember what completing the square entails. Do you guys remember what we had to do to actually complete the square? Matt, go ahead. Right, so what you want to do is you want to take half of coefficient for x okay, that was still messy, whatever. Take half a coefficient for x, square it, and add it to both sides. Now, here's a question I have for you guys. What is a coefficient for x? Yeah, it's not just b, it's b over a. Notice how I'm kind of careful with my wording. I don't want to say take half of b because there's a b involved in this problem. What we're truly trying to do is taking half of the coefficient for x. So let me kind of somewhat rewrite the equation. X squared plus b over a times x equals negative c over a. So do you guys see why I can write bx over a as b over a times x? I can separate it out. Yeah, so really quick, I'll just do it down here and I'll erase it. Let's say I had 4 times 5 over 10, right? We know that's 20 over 10, which is just 2, right? Now, can you do the same thing, say 5 tenths times 4? You still get the same thing, right? So you can totally separate fractions that way. So truly the coefficient for x is right here. So if I take half of it, I got to do half of b over a, which is going to be what? B over 2a. And then if I square it, what do I get next? B squared over 4a squared. This is what we have to add to both sides. I know it's kind of weird because it's letters, not numbers. It was a little easier yesterday when we had just numbers and you had to just take half square and add to both sides. A little bit more challenging when it's just letters, but still the same process. So it's going to be this, x squared plus b over a times x. I'm going to leave a little bit of room here. So we have plus b squared over 4a squared and plus b squared over 4a squared. So still doing the same thing we did yesterday, just again, a little bit weird because the coefficient for x is a fraction of 2 letters, but we're still doing the same thing. Okay, we're okay so far with me here? Okay. This is where it gets a little bit crazy. For step 3, you want to factor the quadratic. So our quadratic is the left side of the equation, right? That's our quadratic. What you're going to want to do what you're going to want to do is do this. Remember, it's a perfect square trinomial, as I showed you guys up here. How do you think I'm going to factor the left side of the equation to put it as a binomial which is a two-term expression squared. What do you guys think? Don't have an idea? Close. X plus b close over 2a. Here's the reason why. The square root of b squared over 4a squared is b over 2a. The square root of x squared is x. If you actually were to multiply this by itself, if you actually took x plus b over 2a and multiplied it to x plus b over 2a and FOILed it, you would get back to the quadratic we have in step 2. You actually would see for yourself that when you do the outside-inside terms, the middle will be b over a times x. It's kind of like, as an example, I'll do right here. How do I factor that? Right. And how do we get the 4x? Well, if I did this, right, I get x squared plus 2x plus 2x plus 4. Well, of course, 2x plus 2x is 4x, right? So it will work itself out. Okay. Now, go ahead. Oh, because, okay, well, actually, let's work it out. So, remember, we have x plus b over 2a and x plus b over 2a. What happens if you were to multiply it out? You get x squared plus b squared over 4a squared. But in the middle, remember, you have x with this and b over 2a with that x, right? So you have b over 2a times x plus b over 2a times x. Both these have the same denominator, right? So it becomes plus 2b over 2a times x, and those twos cancel. So it gets you back to the original equation. Okay, let's look at the right side of the equation, because that's also going to be kind of nuts. I'm going to highlight it right here. So we need to do something about this as well, right? What do you think I'm going to do about that? Go, Connor. Right, we need to find the LCD, which will be just 4a squared. So this means that we need to have this is 4a, and that is 4a. We need to have to multiply this fraction, negative c over a, by 4a and 4a both top and bottom. Therefore, we'll get two fractions with the same denominator. So you wind up getting negative 4ac. What was that? Yeah, it would be 4a squared. I'm multiplying it by 4a, because 4a times a is 4a squared. So the beauty about that is that now we can combine these two fractions. Before we couldn't, now we can. And actually, let's just do that really quick before we move on to our last step. What do you think the last step is going to be? Because we have to solve for x. So just to repeat that, we're going to square root both sides to solve for x. That will be our last step. So step 4, and hopefully you can kind of see how this will get us a quad form. Solve for x by square rooting both sides. So if I were to try blue. If I were to square root both sides, what's going to happen You have this equaling remember, how do you square root a fraction? With a square root of fraction. You square it both top and bottom separately, right? So when you square it 4a squared, you should get 2a. When you square root the numerator, well, nothing you can do about it. It's just b squared minus 4ac. And it had to have plus or minus. Why do we have to have plus or minus? Yeah, because you could have two different possibilities, right? Whenever you solve by square rooting. Trey, go ahead. Because there's a minus in the middle. That's why you'd be displaying the order of operations. So now we're almost there. We move the b over 2a to the other side. And because they both have 2a as their denominators, you can combine it. And there you go. You've got the quad form. Yeah, it's kind of crazy. And now I got to figure out how to